So, good morning, guys. Today's topic is autocollimator. Okay, so let's start. What is autocollimator and the definition? What is the definition of autocollimator? So, we can see autocollimator is an optical instrument used for the measurement of smaller angular difference. Okay, then for smaller angular measurement, it provides a very sensitive and accurate approach. It's essential an infinite telescope and the collimator combined into one instrument. So what will happen in autocollimator? Actually, we are measuring the smaller angular difference of a flat surface or straight surface. Okay, let's see what is the application of the autocollimator for checking a right angle, checking for an internal right angle. Okay, comparative measurement using master angle. So when we are using master angle, comparative measurement we will do. Then measuring straightness and flatness of the surface, any surface. This is the main application or object, you can say. We are measuring the straightness and flatness of the surface through the autocollimator. Okay, then assessment of squareness and parallelism of the component. Actually, what will happen with help of autocollimator, we are doing only measuring the straightness, flatness, squareness and parallelism. Okay, for machine tool adjustment also we are doing, like a lathe machine. Okay, lathe machine adjustment. So here we are using autocollimator and it's an objective, you can see. Actually it's an optical instrument. Okay, now see how it's work and what is the working principle. So you can see, we can see here one light source in there. Okay, here is one type of prism, and the observer who will observe the whole thing, that observer or eyepiece. Here we said our eyepiece. Here is an objective lens. Okay, I will tell you what is the working of objective lens. Then you can see crosshair retailing, then reflected beam and the plane reflected. What will happen when first here some light sources in there, we are emitting the light, it's monochromatic light. We are emitting through where in the prism. After that prism, it will the light source, monochromatic light source, will split up, and after that it's catched by the objective lens. You can see here it will split up, and after objective lens it's going through the only straight line. Okay, and here this is the plane reflector, or we can say the mirror. The working surface is in there. So here we are putting the mirror. If the mirror is accurate 90-degree angle, that time that light will come, that light ray will come and reflect in the same way. If we are giving some angle, or we tilt the mirror some angle like as a theta, that time what will happen, that time that reflection will go another way. This not go the same path, this will go the another way. So here what will happen, we tilt some theta degree angle. When we are giving the theta degree angle, that time the light ray will reflected by 2 theta angle. 2 theta angle, where it will happen, when it's come to the here, after that here to here, we can see here another point. Here another point will come. This is the source point and this is the reflected point. So here some distance is in there. So here you can see the distance is x, and from this portion to objective lens, it's called the focal length. Okay, so we can easily measure the focal length, or the distance of this two ray, the emitting source and the reflected source. Okay, and the reflected result where the point will be made. So that distance is like x, and this is the focal length f. Okay, clear. So here is a calculation is in there. We already study in autocollimator and the angle decker, that x is equal to 2f theta. That means 2f 2 theta is the angle and the f is the focal length. So this is the formula. With this formula we can measure the straightness or flatness. We can, if the surface is flat, that time the reflected point and the emitting point will be the same. If the some distance is coming, that means some flatness, how much angle here is given theta, we can find through this mathematical calculation where x is equal to 2f theta. Okay, so thank you.